Like, subscribe, and hype the video. Also, leave a comment on any topics you want to hear about in the future. Okay, let's dive in. In our last episode, we walked through the Fermi Paradox, the deeply unsettling gap between the numbers that suggest intelligent life should be practically inevitable somewhere in the universe, and the complete, unbroken silence our instruments have returned after decades of searching. The universe is 13.8 billion years old, contains 2 trillion galaxies, and has shown us no confirmed sign of anyone else in it. Today, we're getting into the proposed explanations, and I want to be upfront with you right now. Some of these are genuinely disturbing in a way that isn't dramatic for effect. They're disturbing because the logic behind them is airtight, and the implications, if they turn out to be correct, affect every single person alive on Earth right now. By the end of this video, one of these theories in particular is going to sit with you differently than when we started. Let's get into it. Before getting to the more unsettling theories, let's be fair and walk through the simpler, more optimistic explanations first, because they deserve to be taken seriously too. The first and most straightforward is what some researchers call the rare Earth hypothesis, the idea that the specific combination of conditions that produced intelligent life on Earth is far rarer than the raw numbers of planets suggest. Having the right size planet, the right distance from the right kind of star, the right large moon to stabilize its axial tilt, a large gas giant like Jupiter nearby to deflect incoming asteroids, plate tectonics, a liquid iron core producing a protective magnetic field, and the right chemical composition in the oceans to kickstart biology. The argument goes that all of these factors together make Earth extraordinarily unusual, and that truly Earth-like conditions might be genuinely rare even in a universe with 2 trillion galaxies. A second, simpler explanation is that we simply haven't been looking long enough or sensitively enough yet. Humanity has only been broadcasting detectable radio signals into space for roughly 100 years. Our radio bubble, the sphere of space that our earliest broadcasts have had time to reach, is only about 100 light-years across, in a galaxy that's 100,000 light-years wide. And our active searching has only covered a tiny fraction of possible frequencies, directions, and signal types. On a cosmic timescale, we've been listening for the equivalent of a few seconds. Like, subscribe, and hype the video. And now let's get into the theories that start to get genuinely uncomfortable. This is the one I warned you about. The Great Filter is a theory proposed by economist and futurist Robin Hanson in 1998, and it's arguably the most psychologically disturbing idea connected to the Fermi Paradox, when you fully trace its implications. The basic idea is this: somewhere along the path from simple chemistry to a spacefaring, galaxy-colonizing civilization, there is at least one step so difficult, so unlikely, or so catastrophically dangerous to survive, that virtually no species makes it through. This filter is so effective that even in a universe as vast and old as ours, it prevents the galaxy from filling up with detectable civilizations, which is exactly what the silence suggests is happening. Here's where it gets personally relevant to every human being alive. The filter either lies behind us or ahead of us, and which one of those is true changes the implications completely. If the filter is behind us, if the extraordinarily difficult step was something like the origin of life itself, or the development of complex multicellular organisms, or the emergence of general intelligence, then we got lucky. We already passed the filter. The silence of the universe is explained by how rare our own path was, and the future, while not guaranteed, is at least open. But if the filter is ahead of us, if the reason the universe is silent is that every civilization that reaches our technological level eventually destroys itself, whether through nuclear war, engineered pandemics, climate collapse, artificial intelligence gone wrong, or something we haven't invented yet, then the silence of the universe is a warning, and we are currently approaching the filter, not safely past it. Like, subscribe, and hype the video. And let's talk about what would tell us which of these options is more likely. Here's a detail that completely flips the way most people think about the search for alien life. Intuitively, Most of us assume that discovering life somewhere else in the solar system, on Mars, or in Europa's ocean, or in Titan's atmosphere, would be a cause for celebration. Proof that we aren't alone, confirmation that life is widespread. But through the lens of the Great Filter theory, discovering even simple microbial life elsewhere in the solar system would actually be one of the most alarming possible scientific findings in human history. Here's why. If life arose independently on Mars and on Earth, two planets in the same solar system, it suggests that the development of life from basic chemistry is not actually rare at all. Which means the filter that's keeping the universe quiet probably isn't in the early stages of life developing, which means it's much more likely to be somewhere ahead of us, in the stages between simple life and a civilization capable of surviving long term. Which means the Great Filter is probably still waiting for us. The more common life turns out to be in the universe, the more dangerous the Great Filter theory becomes for our own future. Every simple organism discovered somewhere else in the solar system would push the filter further toward our future rather than our past. That's one of the stranger, more counterintuitive implications of this entire framework, and it's why some researchers genuinely feel a complicated mix of hope and dread about astrobiology discoveries. The dark forest theory offers a completely different solution to the Fermi Paradox, and in some ways, it's even more unsettling than the Great Filter, because it doesn't require any catastrophic self-destruction at all. The theory, popularized by Chinese science fiction author Liu Cixin in his novel The Three-Body Problem, proposes that the universe is silent, not because civilizations are rare or because they destroy themselves, but because every sufficiently advanced civilization has independently reached the same conclusion. In a universe with finite resources and no way to verify another civilization's long-term intentions, the only rational strategy for survival is to locate and eliminate any other civilization before it can grow powerful enough to pose a threat. In this model, the universe functions like a dark forest full of armed hunters. Every civilization hides as completely as possible, because announcing your location to unknown, potentially far more advanced civilizations is equivalent to painting a target on yourself. Any civilization that detects another has strong rational incentive to destroy it quietly, before it gets big enough to become dangerous. The ones that survive are the ones that stayed silent longest. And the reason we hear nothing is not that nobody is out there, but that everyone capable of making noise has learned, through hard experience or cold logic, never to make any. If this theory is correct, humanity's decades of radio broadcasts and active SETI transmissions, deliberately sending signals into space hoping for a response, were possibly one of the least strategically sound things our civilization has ever done. Like, subscribe, and hype the video. And let's cover one more theory before we wrap up, because this one takes a very different and somewhat more comforting direction. The zoo hypothesis proposes the opposite of the dark forest's hostile universe. Instead, it suggests that advanced civilizations are out there, and they know about us, but they're deliberately choosing not to make contact, either to allow us to develop without interference. Similar to the way wildlife researchers avoid disrupting animal populations they're studying, or because they're waiting for us to reach some threshold of technological or social maturity before initiating contact. In this framework, the silence isn't threatening or catastrophic. It's protective, or at least deliberate. Earth would function like a nature preserve or a protected development zone, with our corner of the galaxy essentially fenced off from direct contact until we demonstrate we're ready for it. This theory has some appeal as a solution, but it faces a real logical challenge. It requires every single sufficiently advanced civilization in the galaxy to independently agree to the same non-interference policy, without exception, across billions of years. Because it would only take one civilization, or one faction of one civilization, to break ranks and make itself known, to shatter the entire arrangement. The coordination required makes some researchers skeptical that even a well-intentioned galactic community could maintain this kind of universal silence indefinitely. So here's where all of these solutions actually land. The simple explanations, rare earth not looking long enough, are comforting but increasingly strained as our instruments improve and the silence persists. The great filter is logically airtight, but divides into the most hopeful and most terrifying interpretations depending on a single unknown. The dark forest is rationally coherent, but implies a universe so hostile that our broadcasts may have been a serious mistake. And the zoo hypothesis is appealing but requires a level of universal coordination that's hard to justify without more evidence. None of these theories has been confirmed. All of them are serious enough to have been published, debated, and defended by credentialed researchers. And the fact that we still can't rule any of them out, after decades of searching and improving technology, is itself one of the most thought-provoking things about being a conscious species in a universe this old and this large. Fermi's question, asked over lunch in 1950, still doesn't have a clean answer. And depending on which theory turns out to be correct, that might be either the best or the worst news in the entire history of science. If you've made it through both episodes, let me know in the comments which solution to the Fermi paradox you find most convincing or most terrifying. Like, subscribe, and hype the video, and I'll see you in the next one.